Let's look at number 5. You have a spring, you have mass attached, so it'll be oscillating, but it looks like there's block coming down. Probably you have to deal with like momentum, and if they stick together, that's completely inelastic collision, right? And well, let's think about it. Completely inelastic collision, when one mass goes and meet with another mass, and they stick together and move together, right? And here, what I know is momentum before collision, which is just mv, equals momentum after collision, which is m plus large M, I call it b prime. These two has to be equal because you only have internal force and momentum is conserved, but kinetic energy will be decreased. Okay, compare. So basically what I mean is 1/2 mv squared is initial kinetic energy, and final kinetic energy is 1/2 m plus m v prime squared. This is final kinetic energy, but this will be bigger because you lose kinetic energy, and actually you lose maximum kinetic energy when it's completely inelastic, when the two mass stick together. Okay, now what's happening? So you have mass m, this guy, spring constant k, the below oscillating period Tp, amplitude AP. So we're dealing with period and amplitude of this one body. And a second block of Q of mass 2m, so this will be 2m. It dropped from rest at Landon block P at an instant it passed through equilibrium. Okay, so there is like a collision, right? Now this becomes 3m, I guess. And two block system oscillate with different period and different amplitude. Amplitude should be different, but we'll see. So what did I ask you? Determine the numerical value of period. Okay, so period of simple harmonic motion for AP Physics 1, you need to know a period of pendulum, which is 2 pi radical L over G, but not in this question. In this question, period of spring, which is 2 pi radical M over K, so that is the period you're looking at. And PQ is the case when they stick together, so this one has mass of 3m. TP is just the single mass of m, right? So basically TPQ over TP is 2 pi radical 3m over k over 2 pi radical m over k, and you can reduce this. And for this complex fraction, let me just give you a little shortcut. If you have a over b over c over d format, I will make another lecture on this, but let's go over quickly. One shortcut is outside goes to top, inside goes to bottom. The reason is this is actually same as a over b divided by c over d, which is a over b times d over c. I know a lot of times you learn it this way, which is AD over BC. But since this comes really often in physics and math, especially in SAT, I just want you to memorize outside goes top, inside goes to bottom. So in this case, and you can also reduce this, but I'll just leave it. But if you outside is 3mk and inside is mk, you can just cancel. So you'll get radical 3. That basically means period increase. This also means this takes longer, okay? It's radical 3 times longer, ideally. I mean, basically, which is about 1.73 times longer, okay? All right, so I know, okay, so this was radical 3, right? All right, how about B? The figure is produced above. How does amplitude change this? Well, amplitude has to deal with energy, right? The mechanical energy. So you have 1/2 mv squared, and I'm talking about equilibrium speed. At the equilibrium, the only energy you have is kinetic energy, because potential energy of a spring, which is half kx squared, will be 0 because x will be 0 at the equilibrium. Okay. Now this becomes at the amplitude, your kinetic energy becomes 0, so all the energy is converted to the potential energy of spring, which is 1/2 k a squared, and we are interested to find out this guy, right? All right, so from here you have you can cancel half, and acceleration, no, amplitude squared will be mv over k, right? And basically the amplitude is this. But here, v equilibrium will actually smaller, right? While mass actually increase, so it gets a little tricky. So I'll just go over different approach, okay? And I already know, amplitude has to be smaller, but I'll prove why, okay? So if you look at kinetic energy, which is 1/2 mv squared, which is basically 1/2 mv times v. So sometimes you actually use this expression. This mv is actually momentum. This is 1/2 momentum times v, right? This is actually a good way to analyze, because when you have collision, you have one mass, a certain velocity v. But remember, there was m here, there was 2m comes down, and it goes with, let's say, with v prime, okay? But this is completely inelastic collision, so, and momentum has to be conserved. So you can say mv equals 3m, that's the total mass now, times v prime. And kinetic energy of, so basically this mv part is the momentum, is same, right? So this part is not gonna change, okay? Because momentum before collision equals momentum after collision, so this p has to be constant. But if you think about this v is initially you had v, but now your v prime, which is the final speed after collision, will be 1/3 v, because you can cancel mass. V prime will be 1/3 v, right? So that means this guy initially was 1/2 pv becomes 1/2 p, because remember p does not change, over v over 3, right? So basically your kinetic energy will be 1/3 of your original, okay? And since your kinetic energy is small, your amplitude has to be small too. So your amplitude of PQ will be smaller than amplitude P, right? So another way to elaborate this is, you can say because of the collision, kinetic energy decreased. So the left side of this equation, kinetic energy decreased. So amplitude has to decrease because K is constant, okay? So that's one way to write this. But I think this analysis is actually pretty good. So again, I'll write this down. Kinetic energy is 1/2 mv squared, but also kinetic energy is 1/2 momentum times velocity, okay? All right. That's it for 2018 AP Physics free response. All right. Bye-bye.